Hello and welcome students, welcome back to my channel. Today we will be discussing in this video the electromagnetic spectrum of electromagnetic wave. Spectrum of electromagnetic wave. So what do we mean by spectrum? Electromagnetic waves, they span over a wide range of wavelength or frequencies. So if we arrange all the waves in ascending or descending order of wavelength or frequency, then such an arrangement, okay, will be known as a spectrum. So in spectrum you can clearly see the different waves in the increasing or decreasing order of their wavelength or frequency, either way. Right, students? So in the last two videos we have already covered the other aspects of electromagnetic waves. So you can just go through those videos, students, if you have not gone. And this would be the last video of this electromagnetic chapter, and this will be particularly useful for your class 12 board as well as Neet and JEE Mains. Again I am telling students because short you will be getting one or two questions in JEE Mains as well as Neet, and in the final exam class 12 board also there are high chances that you get a question, at least one question from this chapter. And this chapter is very easy, so it's very easy to score marks in this. Okay, students. So in this video we'll be purely focusing on the spectrum of electromagnetic wave. Okay, students. Now, as we know that here you can see I have come up with this a schematic diagram of different waves. Okay, as you can see, all the what you call these different waves of electromagnetic waves have been arranged in ascending or descending order of wavelength or frequency. Here you can see gamma rays are at the top. That means they have the highest frequency. You can see, students. Okay, and or naturally they'll have the lowest wavelength as well. And at the bottom you can see there are radio waves which have shortest frequency, minimum frequency, in fact, minimum frequency, but at the same time their wavelength is maximum. Right side you can see, right side you have wavelength, students, you can see this wavelength, whereas left side you can see the corresponding frequency. It is just an order of magnitude. Okay, and most important thing you have to realize that there is a slight overlap between different electromagnetic waves. For example, you see, students, in this region the gamma rays are overlapping with X-rays. Can you see this? Somewhere in the region 10 power minus 11 meters to 10 power minus 12 meters. Similarly, you can see, students, in this region the X-rays are getting overlapped with the ultraviolet light. Somewhere in the region 10 power 8 minus 8 meters to 10 power minus 9 meters. Okay, similarly you can see in this region microwaves and infrared waves are overlapping. So what we mean to say is that basically there could be slight overlap. Okay, now they have been named different in a different manner based on the way they are produced. Okay, the method by which they have been produced and the detectors required to detect them, based on that they have been classified. Also there will be corresponding variation in their energy of quantum also. Students, in this aspect I would like to tell you that if it is a light quantum, then it will be specifically called as a photon. Otherwise you can call it as quantum. Okay, but in most of the books they use the word photon, which is not very correct. Photons are supposed to be used only for visible light. For all other electromagnetic energy packets, you should use the word quantum. Okay, so in a sequence, let us see. So gamma rays appear to be at the top here. They have the highest frequency. Then comes X-rays, then ultraviolet, then visible light, then infrared radiation, then microwaves. Then you have radio waves. Radio waves can be broadly classified into short radio waves and long radio waves. Okay, radio waves means basically they carry information related to radio communication. Okay, students, and this visible light is the one which activates our retina, or which helps us to see outside objects. Though in itself it's not visible. Okay, visible light is not visible. Light is not visible. Light helps us to see outside objects. So visible light spans roughly over this 400 nanometers to 700 nanometers. and you can see 400 nanometers corresponds to violet light, whereas 700 nanometer corresponds to red color, and rest all the colors are in between. You can see this, students. So you have to memorize, and our eye is most sensitive to this part, somewhere around 550 nanometer. It lies in the greenish yellow region. You can see. Okay, because since time immemorial, human beings have evolved looking at sunlight, and the most dominant wavelength in the sunlight is this. So perhaps that is the reason why our eye has become more picked up more sensitivity towards this wavelength. Okay, right. So now one by one we'll see, students. Okay. So here comes your radio waves. First and foremost. Okay. So this is the first this thing, radio wave, starting from the bottom. Now you can see, students, it has a wavelength somewhere around perhaps less around zero point 0.5, maybe sorry, students, I'm sorry, since we are discussing radio waves, the wavelength could vary somewhere, in fact, yes, zero point 0.5 millimeter to maybe 10 to the power 4 kilometers. So it can span up to several kilometers. This is the wavelength I am writing, students. Okay, frequency we'll discuss very soon. I'll come back to this, don't worry. And the energy of the photons is very, very less, probably less than 10 to the power minus 6 electron volt. Very less, negligibly small. Okay. Now they are produced by strongly, when electrons are strongly accelerated or decelerated. Okay, in a what you say, in a wire, in a copper wire or in any metallic wire, when electrons and when free electrons are accelerated or retarded quickly, then these radio waves are produced. Okay, so I'll write this here. Production wise, when electrons are strongly accelerated or decelerated in a circuit containing wire, simple wire. Okay, so on this aspect we call this as antenna. Okay, antenna. And in the olden days you used to call this as aerial. So aerial is basically an antenna, you can think. Okay, now automatically it will be detected by an antenna only or an aerial. So radio waves are detected by through an aerial or an antenna, right? Now coming to uses, basically, students, radio waves, the name itself indicates that it is purely employed for radio communication. Okay, students, it is purely just a minute, students. It is purely employed for radio communication. Okay, what happened? Anyway, let us continue with this. Okay, so now in radio waves we have amplitude modulated band. Okay, so here basically they use frequencies of the order of, let us say, around 530 kilohertz to around 1710 kilohertz. So 1710 kilohertz means roughly it is 1.71 megahertz. Okay, then you have short wave band also. All these are used for radio communication. Okay, So shortwave band, the frequency ranges from roughly around 3 megahertz or 3 million hertz to maybe around 30 million hertz. Even though in the CBSE textbook it is given as around 54 million hertz, but above 30 million hertz, basically it is of no use actually, or probably we are not using that part. Okay, students. Then you have TV waves, television waves. Okay, the different programs of televisions are relayed through this TV waves, and the frequency ranges somewhere from 54 million hertz to around 890 million hertz. Okay, students, you have to remember these values because in the Neet as well as JEE mains, they precisely ask these values. So you have to be very careful and you have to memorize this. Okay, and finally we have frequency modulated waves. Remember, students, FM waves will require higher frequency range. So here the frequency range spans from 88 million hertz to maybe around 108 million hertz or megahertz. Okay, students. So all these are radio waves. Also, what we call our cellular phones, that is mobile phones, they employ UHF, that is ultra high frequency waves. Full form is ultra high frequency waves. Okay, and they span from over 300 megahertz, the frequency ranges, to around 3 gigahertz. Okay, this part overlaps with the microwave, students. Even though it's a part of radio wave, but it gets overlapped with microwaves. Right, students? Okay, right. And regarding the frequency, roughly I can write the frequency. Frequency range will be something like this, around 500 kilohertz to 1 gigahertz. 1 gigahertz or 1000 megahertz. Both are one and same only. Okay, students. Then moving on to the next wave, that is microwaves. So next comes microwaves. Now the wavelength range is roughly from around 1 millimeter to around 10 centimeters. Okay, students. And the energy is ranges from 10 power minus 3 electron volt to roughly around 10 to the power minus 5 electron volt. Okay, students. And frequency is of the order of gigahertz, few gigahertz, of course. Okay, so they are produced by special valves which are named as klystron valves, and magnetron valves. These are the special devices which produce what we call microwaves. And also there are certain diodes known as gun diodes. They too produce microwaves. I'm sorry. Okay, students. Then the uses, we have so many uses. First and foremost, the most important use is aircraft navigation. This question has been asked in JEE mains. Which of the following in match the column they have asked. So microwaves are exclusively employed for aircraft navigation. So I hope you understand the meaning of navigation. The aeroplane is able to know its exact location while flying mid-air as to in which direction it is moving and exactly where is it lying at that point of time. So this helps the pilot to properly fly the plane. Then apart from that, in students you might have seen that in cricket and all, they are able to detect the speed of the ball. Also in roadways and all, the traffic police is able to detect the vehicles which are over speeding, which are crossing the upper limit of the speed. So all this can be timed with the help of radar, and radars exclusively use microwaves. Okay, students. So just to name a few, we can time the balls, cricket balls or even tennis balls and all, and also we can check the speed of automobiles if whether they are crossing the safe speed limit and all. So these are different, and most important of all, hopefully we all know this. We have microwave oven. All of us nowadays have this microwave oven because it comes very handy in heating anything or boiling anything and all. So basically, the food stuff is irradiated with microwaves. Okay, microwaves have a special property that the energy of the microwave quantum, okay, is of the order of the kinetic energy due to rotation or vibration of water molecules. Okay, somewhere around 3 gigahertz, and the frequency is 3 gigahertz. Frequency of the water molecules is 3 gigahertz. They keep rotating with this speed, and also the approximate frequency of these microwaves is also somewhere around gigahertz only, few gigahertz. So what happens that when a food containing water is irradiated with microwaves, the water molecules are easily able to absorb those microwave quanta and hence get heated up, which in turn heat the neighboring food molecules. So as a matter of fact, we all know that any food will certainly contain water, and it is because of the presence of water that microwaves are effective in heating it. For example, potatoes, brinjals, everything will have water. So raw potato or raw brinjal can straight away be cooked by microwave without any additional water and all. Okay, students. Right. Now coming to the detector, they are detected by what we call point contact diodes. Point contact diodes. They are special types of diodes employed to detect these microwaves. Sorry. Then moving on to the next this thing, which is the infrared radiation. Now, students, infrared radiation we all are aware of this right from the early childhood. We have been learning, and we commonly call them as heat waves. Okay. For example, when you stand in front of a stove or a hearth or a furnace, you can feel the warmth. So that means some radiation are incident on your body, which is giving you the feeling of that warmth. These radiation are infrared radiation. They are not at all visible. You cannot see them. Neither they help us to see, but you can definitely feel the warmth. So they are all infrared radiation. Okay, students. So infrared radiation, the frequency, I mean wavelength. Sorry, first we'll see. Wavelength ranges from roughly around 700 nanometer to around 0.5 millimeter. 0.5 millimeter, and what we call the energy is of the order of 10 to the power minus 3 electron volt. It's very less, in fact, very less. Okay. Then coming to production, any hot body will be able to emit heat rays. It can be hot milk, it can be hot cooked food. Any hot body will emit heat. So basically, heat is emitted from the molecules of the body. So all hot bodies and molecules of bodies are in a position to emit what we call heat waves. Am I clear, students? Then coming to the uses, we have different uses, students. For example, what you call as infrared lamp. Infrared lamp. Okay. So it is used in physical therapy. Okay, in providing warmth. For example, a cold stricken person, a person who has been struck with cold, he will be provided warmth through an infrared lamp only. For example, newly born infant or a old people, old person. Also, since it provides warmth in many sores, in order to heal sores and different wounds, they provide infrared radiation through infrared lamps. So, in medicinal, it has a lot of application in physical therapy. Students, okay. Then we cannot forget about the infrared cameras. Infrared cameras are there, in particular in fighter planes. Fighter planes and all, they use infrared cameras to see within inverted comma during night. Okay, they'll be flying at high altitude, high enough not to be able to be detected to anything during night, and they can see what is there on the ground through infrared cameras. Okay, and also in military equipments and all, they keep using infrared. This thing. Then, even in our day-to-day life, all of us use remote controllers for televisions or record players or any hi-fi system, anything. So they have basically light emitting diode. They emit infrared radiation. The moment you press the button of remote, actually infrared radiation come out and they operate the television or whatever it is. Okay. And most important of all, we have greenhouse effect. We all are aware of this greenhouse effect. Okay, students. So, in short, I'll explain you what is this. The solar radiation, it directly penetrates through the atmosphere and reaches the Earth's surface. Earth absorbs those radiation and it re-radiates back towards the atmosphere in the form of longer wavelength, basically infrared radiation. Because solar radiation have X-rays, ultraviolet, visible light, so many things. But when Earth re-radiates that solar light after absorbing, it is only in the form of infrared radiation. So these infrared radiation, they are not able to cross the atmosphere because atmosphere essentially contains CO2 and H2O. So carbon dioxide molecules and H2O molecules, they are all greenhouse gases. H2O in the form of vapor, I am telling. So they don't allow the infrared radiation to go out. So basically this heat radiation get trapped within the Earth's atmosphere, thereby providing the necessary warmth to the planet. Otherwise, many lives will become extinct without that thing. Okay, student. So very important thing, particularly for small plants and all. Greenhouse effect is very important for proper growth. Okay, students. Then coming to detectors, I mean anything can detect this infrared radiation. Particularly, if you talk of instruments, you have thermopile, then bolometer. Okay, thermopile is basically an instrument which works on the principle of thermoelectric EMF. Thermoelectric EMF. When two different rods are joined end to end and the two ends are maintained at different temperatures, an EMF is produced and current flows. Then bolometer is basically made up of resistances. It measures the change in resistance due to temperature of platinum wire. Okay, and even temperature measuring thermometers are also there. For example, alcohol thermometer. Alcohol thermometer can also be used to detect infrared radiation. And also, it is said that snakes are very sensitive to infrared radiation. So, in fact, just like visible light help us to see outside objects, snakes are able to see their outside world with the help of infrared radiation. So, if any animal is there, that animal will keep radiating infrared radiation, and the snake will be able to detect that infrared radiation, thereby exactly locating the position of the animal. Okay, students. Then, coming to visible light, we all know visible light is a small part of the electromagnetic spectrum. Basically, the wavelength ranges from 400 nanometers to roughly around 700 nanometer. This 400 nanometer corresponds to violet and 700 nanometer corresponds to red. Rest all the colors lie in between. Okay, and in order to provide the their energy will be somewhere in the range of 1.6 electron volt to 3.2 electron volt. This is the normal energy range of this. And wavelength wise, if we have to see, then wavelength, what you call, frequency wise, so it is of the order of 10 power 14 hertz, roughly, of the order of 10 power 14 hertz. Production, we know that in hydrogen spectrum, Balmer series corresponds to the visible range. You all know this Balmer series. So in certain electrons, in certain atoms, when electrons jump to lower energy states from higher energy states, that is when atoms tend to regain the ground state from excited states. Then they eject the excess energy, and if that energy happens to be in this range, so then certainly light will be emitted. So basically, it is emitted with excited atoms, atoms in the excited state, when they tend to come back to the ground state. Okay, students? Right. Now coming to the what you call applications. Basically, due to this short wavelength, due to their wavelength is very less. You can see the wavelength, students. Wavelength is. I'm sorry. We are discussing visible light. Okay. Uses I am just leaving it because we all know the different uses. And as far as detector is concerned, we can use a photographic plate. Photographic plate can be the best detector. Okay, students. Right. Next, moving on to the next this type, that is ultraviolet rays or ultraviolet waves. Their wavelength ranges from around probably 700 nanometer, which is the upper range of the violet color, to roughly around 10 degree angstrom. This is the wavelength range, and energy wise, I can write that it varies from 3.2 electron volt to roughly around 100 electron volt. Okay, students, and production wise, they are produced by special lamps and extremely hot bodies. They are produced by special types of lamps and extremely hot bodies. Extremely hot bodies. Okay, students. And coming to the application, as I told you, because of their short wavelength, they can be focused to a very narrow beam, students. They can be very easily focused to a very narrow beam, and that entitles it to be used in the form of a LASIK. This question was asked recently in JEE Mains. So LASIK is basically, the full form is laser assisted in situ keratomyeliosis. This is the full form. So it's a kind of eye surgery actually. Okay, particularly cataract and all. For cataract and all, eye surgery can be done with this technique. They use microwaves. Okay, students. Also, most of us have water purifier or water filters in our house. There you can see a tiny lamp there. Ultraviolet lamp will be there. So this ultraviolet lamp emits ultraviolet radiation inside the liquid, inside water, and it tends to kill the germs there. So basically we have in purification, it is used in water purification. Purification of water. Almost all the water purifiers, they have this ultraviolet lamp. Okay, students. Then second thing, you have to understand that in the atmosphere, sunlight is a strong source of ultraviolet light. Sunlight, there is a lot of ultraviolet light, and ultraviolet light is very dangerous for human beings. Prolonged exposure can lead to severe diseases like cancer and all. So in such a case, what is to be done? we have a natural protective layer, that is ozone. Ozone is around maybe 40 to 50 kilometers, 30 to 50 kilometers above the Earth's surface. There is a ozone layer in the atmosphere. It absorbs properly all the ultraviolet light, thereby allowing only the rest of the part of the light after ultraviolet light is being absorbed. So the light which we get on the Earth's surface is very poor in ultraviolet. That is that is the good news for us. Okay. So moreover, the ordinary glass, they are good absorbers of ultraviolet light. Ordinary glass is a very good absorber of ultraviolet light. So, like during welding and all, you would have seen people wearing a face mask made up of glass. That's ordinary glass. So the brilliance, that is the shining, will not affect the eye. Otherwise, what will happen? Ultraviolet light is very dangerous for the eye also. So, but since glass does not allow it to, glass absorbs ultraviolet light, so the person can safely do the welding work. Okay, students. Right. Then we'll move on to the next what we call type of electromagnetic wave, that is X-ray. Okay, students. So here X-ray, where is X? So here you can see they they are slightly highly energetic. This, so the maybe I write the wavelength ranges from around 0.01 degree angstrom to roughly around 100 degree angstrom. Okay, students, and energies are of the order of 40 to 150 kilo electron volt. Even they can be more than this, but this is the usual range which is employed for diagnostic purpose. For example, if you have any bone fracture or something, we know you have to take an X-ray. So the X-rays which are used for diagnostic purpose, they employ soft X-rays, X-rays having less energy. So these are soft X-rays energies. So the person has to be exposed for a very limited span of time, because prolonged exposure of X-rays can lead to severe causes, severe damages. So we have to be very careful there. Okay, students. Then, now how they are produced, I'll come up with a separate video for X-rays and all. Okay, particularly for X-rays, very soon I'll come up with a separate video. So for now, briefly we'll understand how it is produced. When fast-moving X-rays are abruptly stopped by a heavy target, that means fast-moving electrons are made incident on heavy target like molybdenum or tungsten. Then these abruptly decelerated electrons result in X-rays. X-rays are produced out of it. We have primary X-rays, secondary X-rays, all those things I'll cover in some other video. Okay, students? So, when fast moving electrons are stopped by heavy metal atoms, X-rays are generated. So, that is how X-rays are generated. When fast moving electrons, just a minute, spelling mistake is there. So fast moving electrons are abruptly stopped by a heavy metal, okay, molybdenum or tungsten, then X-rays are generated. X-rays are generated. Okay, students. Then coming to the usage, so it has medicinal use, as we know, because it is exclusively used for diagnostic purpose, to diagnose the inner parts of the body like bones and all. If there is a bone fracture and all, so medicinal value in medicine or okay, medicine, medicinal purpose, diagnostic purpose. and also it is employed in treating certain kinds of cancerous growth cells, okay, in certain forms of cancerous, because they are highly energetic quanta, so they can easily kill the cells very easily. So cancerous cells can be the growth of cancerous cells can be prohibited or retarded by the proper use of X-rays. So treatment of cancer also could be the treatment of cancer could be the other use. Okay, students. Coming to detector, of course, photographic plate is the best thing. Photographic plate is the best detector. X-rays can be detected very easily by photographic plate. Okay, students, they are highly energetic. Sorry, I'm sorry. Yes. Now, finally, we have gamma rays. Now, these gamma rays are the highest energetic, uh, what you call waves of the electromagnetic spectrum. Okay, their wavelength ranges from 0.01 degree angstrom to 100 degree angstrom. Okay, and I'm sorry. This is for X-rays. I'm sorry. This for zero point 0.5 degree angstrom to around 10 to the power minus 4 degree angstrom, and their energies will be of the order of 100 kilo electron volt to 10 million electron volt. They can range beyond this also. This is a rough this thing value I have given. As far as production is concerned, it is produced during radioactive decay, we all know, and also in certain kind of nuclear reactions. Okay. In nuclear reactions and radioactive decay. Nuclear reactions and radioactive decay. Okay. Then, and the main use, there are a lot of uses, but the main use is again for medicinal purpose. Again, almost similar to that of X-ray, like they can be used to diagnose. Okay, sorry, not diagnose. I'm sorry. They can be employed to kill the cancerous cells. Growth of cancerous cells can be stopped by the using of this what we call this type of rays. So basically, usage we can write to destroy cancerous cells. Okay. Prolonged exposure to gamma rays is extremely dangerous. It can straight away lead to cancer, students. So people who work in nuclear reactors, they are given special aprons made up of lead, because lead are good absorbers of gamma radiation. So the body should be thoroughly protected with gamma radiation. Okay, otherwise it can lead to severe consequences. Then, as far as detector is concerned, again, students, the best detector could be a photographic plate. Photographic plate could be the best detector. Okay, students. So now the type of questions which they ask in JEE Mains and Neet is like this. They'll ask you in which spectrum of the electromagnetic wave does it lie. That means they would ask you to identify whether it is microwave or X-ray or what. So the trick is either you can find the wavelength or frequency, of course, or energy. They'll be giving you a clue either to find the wavelength or frequency or energy. Of course, wavelength and frequency are interrelated. We all know this, isn't it, students? Wavelength and frequency is interrelated. So if you can find frequency, means you can find wavelength. That's not a matter. Or else they might give you a hint to calculate the energy. So based on energy or wavelength or frequency, you should be able to exactly tell what is the nature of the electromagnetic wave, whether they fall under the category of X-rays or ultraviolet rays, etc., etc. So this is how we have to handle. Now coming back to this, finally you can see students once again. Okay, you can see the gamma rays occupy the highest position. You can see the wavelength ranges from around somewhere below angstrom unit. You can see because 10 power minus is 1 angstrom, so below 1 angstrom. And X-rays, they span from zero point zero 0.01 angstrom to around 100 angstrom. Okay, students, and this visible light is from 400 nanometer to 700 nanometer. Ultraviolet light from 400 nanometer to around zero point 0.1 angstrom. 10 power minus 9 is 0.1. All this we have already discussed, students. Okay, so you can go through this and you have to memorize this, students, everything. Okay, that's all in this video. Thank you so much for watching.